Every good engraver's kit starts with a good hammer, and I started with this hammer. Let me tell you, friends, this was not a good hammer to start with. It was my grandfather's, the tradition of which is always nice, but if you ask me, it needs to lighten up a bit. So rather than spending $20 on a new hammer, I set out to spend 20 times that amount to save money making one. It all started with this maple tree that spontaneously died on me last spring. Not one to leave my botanical failures standing around, I decided this was the perfect tree from which to craft a mighty hammer. So I cut it down, trimmed the excess, and turned my metal lathe into a wood lathe for the afternoon. Originally, I had planned to make the hammerhead from some mild steel, but considering that I accidentally became a woodworker that fateful afternoon, it was a good save from PCBWay, the hammering sponsor of this video. That's right, we're finally turning a dime here at Pearlybrook, and right on time, too. Hammer time, that is. Rather than soft, pliable, mild steel, PCBWay has a full gamut of tool steels to choose from. I landed on S7, which I've never heard of, but according to this handy write-up, makes for excellent hammer material. Cold bluing? Yes, please. And to complete the professional hammer time look, let's give this puppy a premium finish. Easy as that, and I have my new hammerhead, with a quick polish of the faces, and an even quicker shaping of the handle's wedge. I can jam this handle straight into the eye of this head, and presto, the hammer I've always dreamed of. Well, the dream didn't include these cracks, but surely that won't matter in the long term. When all one has is a hammer, every problem looks like a nail. So the ancients foretold. But I only have screws, so I need to make that nail. I started my graver journey by cutting apart some tool steel sheet that I had on hand. If you're making your own gravers, I would not recommend starting with sheets of metal, but with a bit of persuasion, I wrangled this sheet into something approaching 1/8 of an inch square. The advantage of starting with annealed tool steel, compared to something like high-speed steel blanks, is the relative ease of initially shaping it, since it's soft enough to file into submission. I devised an elaborate system of a handle, made from some black walnut my cousin gave me, and custom ferrules. The ferrules slide on and off, my attempt at some sort of quick-change tooling system. The handle stays the same. The ferrules hold different tools, and I swap between them at my leisure. The results weren't terrible, for my skill set anyway, and yet I still found the handle wanting. I can't really put my finger on why. It functioned fine, albeit it would function better with a clearance flat filed off one side of it for those low-down angles, if you know what I mean. But something was missing. Perhaps it was my forlorn machinist soul speaking from under a mountain of sawdust. Perhaps it was just indigestion. Or perhaps it was the looming prospect of needing to make at least 3 more of these stainless steel ferrules. In the end, I gave in to the indigestion and grabbed some of this round 01 tool steel I had slated for a different project. Oh, the gravers I made with this steel. The simple yet rugged design fostering my copying skills as I searched for the perfect Goldilocks-esque graver geometry that was just right for me. V-point gravers. One small, one large. Useful for shading, though I'd have skipped the smaller if I hadn't made it first. It's too small for anything but the finest of details, and my current skill level is too big to tackle something so small. A flat graver. Good for hogging out background material or making very wide cuts with a twist of the wrist while hammering. This one is perhaps a bit too large, but I already had a small one I made for the ferrule system, and I've found use cases for both already. Ah, but if I had only one graver to take to my grave, it would be the next. Gaze upon its gloriously curved sides, that plump 120-degree angle, that delightfully shiny face. Well, just ignore this little bump here. I accidentally smacked this puppy into the edge of the glass quenching container while it was red hot. Speaking of, if you're unfamiliar with the basics of heat treating, you're far better off finding some other YouTuber to learn from. But I suppose, since you're here already, I should give a quick synopsis, as if I hadn't just learned this 2 weeks ago myself. The process goes as such. Step 1. Heat. The typical advice is to heat the steel to a cherry red color. Having some disagreements with the merits of color myself, I usually just heat it until it stops changing colors. If you want to measure more empiric than color, though, you can use a magnet. Through a magical process known as science, steel loses its magnetism somewhere around the temperature at which you want to quench it. Which brings us to Step 2. Quench. This is O1 tool steel. The O stands for oil. So find the nearest deposit of oil and throw this hot poker straight into it. Step 3. Polish. Seriously, this step is actually important for reasons we will get into in Step 4. Tempering. The whole reason we have a Step 3 is to prepare for Step 4, which is this step, which is tempering, which is the step that partially undoes the combined efforts of Steps 1 and 2. For a tool like this, which happens to be the only type of tool I've ever heat treated, a process known as drawing the temper works best. Apply heat to the pointy stick, not at the tip like before, but somewhere down away from it. As the steel heats up, it will change colors, from this point, growing out towards the ends of the tool. The very edge of this color change is what matters. I hear it's something of a straw color, but I don't really know what that means. So just watch the edge of it. When it reaches the tip, immediately stuff that hot pointer into the nearest water reservoir. Water this time, not oil as before. It needs to stop heating as quickly as possible, and water is much better at doing so than oil. The astute amongst you will have figured this out by now, but being able to clearly see the color change is why Step 3, polishing, is so important. Remember to keep your tip clean and shiny, for whatever marks the end of these tools will inevitably mark the ends of your patience as these imperfections manifest in your engravings. Continuing the theme of pretending to be an expert in matters I just started learning myself, let's get into graver geometry. The cutting faces of all these gravers are angled back to something around 45 degrees. I haven't explicitly tried any other angles here, but the exact angle isn't critical anyway. And as such, in a surprising narrative twist, none of these gravers are actually 45 degrees after all. These angles on the sides of the cutting face form what's known in the engraving world as the heel of the graver. Being something of a foot enthusiast myself, I can attest to the importance of the heel. I aimed for a seemingly standard 15 degrees on these, but again, the exact values are not critical. What is critical is that the combined geometry of these two faces comprising the heel be centered. I made the mistake of accidentally grinding one side further than the other on one of my early attempts, and the results were extremely frustrating. The second critical aspect of the heel is its length. Too short, and your graver will want to dig into the material. Too long, and you will be fighting to keep the tool engaged with the work. Multiple resources I found mentioned something in the range of 0.5 millimeter. For the heel grind on each side. In practice, I found that initially grinding the heel shorter than desired, then walking it out to length in between some test cuts, was the method I preferred over trying to hit any specific length measurement. This iterative method ensured I didn't overshoot the heel length, which is far worse than the alternative, since the only way to correct an overshoot is by grinding the entire face of the graver back. A tall order when you're shaping these things with bench stones and an old knife sharpening kit. Sam Alfano, an infinitely more experienced engraver than I, showed a trick for setting the heel in one of his videos that I will link to below. The basic idea is to get a piece of steel, ideally hardened so it lasts a while, about 1/8 of an inch thick, set on top of a stone. Rest the side of the graver on it, and sweep back and forth a few times. The height of the steel block sets the angle to roughly 15 degrees without much effort. Second in unexpected importance to the hammer, in my experience anyway, is the necessity of smart work holding. Whether you engrave standing or sitting, you will want some way to move the work to a comfortable height for both your arms and your eyes. The good news is that the forces necessary aren't very high, so good, wholesome, cheap, and easily adjustable wood works just fine as a base for us beginners. My first setup, worth mentioning, was a clamp-on vise, clamped to the end of a 2x6, screwed to the top of a scrap piece of 4x4. All held upright by this monstrosity of a machinist's vise. I'm sure if you're following along at home, you will have no trouble sourcing all of these materials. This setup works alright if you can unimpededly walk around the work while engraving. Ultimately, though, I found that some sort of swiveling work-holding apparatus was worth the effort. For me, this was simple, as I had a swivel base for my mill's vise sitting unused in a box. I made up a small fixture plate with a precisely bored hole in the middle for the swivel action, and mounted my bench vise to the top for the actual work-holding. This setup works well, with the notable exception of when I am engraving on the far end of some large plate. In this precise use case, I have to lock down these retaining bolts because the increased leverage on the ends of wide parts transfers into some slight undesirable rotation in the base while hammering. This vise in particular turned out to be a mistake, which I will explain in a moment. Holding small, thin sheets in a regular bench vise has always been a nuisance, so I quickly pulled out some PCB manufacturing knowledge I had bouncing around in the old noodle. By laying down some masking tape onto a block, and again onto the bottom of the part, and applying some superglue in between, unimpeded access to the entire work surface becomes trivial. The tape allows for quick and simple removal of the part as opposed to just gluing it down directly. Since I was just gluing parts to blocks of various material anyway, the vise quickly lost purpose. In fact, it became a nuisance. The handle sticking out the back often got in the way of my graver holding hand, forcing me to reposition. So I ditched the vise, and instead screwed a block of cast iron to the top of the fixture plate directly. The result was an immediate notable improvement in the quality of my engraving. You can clearly see it here. The first engraving was engraved with the vise in place, the second without. The lines in the second are much more consistent. You can actually point out the places in the first where the vise's handle got in the way mid-cut. In my brief foray into engraving, the skill I've found to pay the best dividends doesn't actually involve engraving at all. It's in drawing. Even if you never intend to design your own scrollwork, the experience of drawing circles, curves, and shading is all directly transferable to engraving. Learning how to move the hand in conjunction with the eye to form an S-curve, for example, is roughly the same whether it is being drawn or engraved. I prefer to practice by attempting some sort of completed scrollwork, but really you would be much better off just drawing out some basic shapes repeatedly until you feel you have a good grasp of how to form them. The effort expended in sketching out a complete design on paper can directly transfer over to metal as well. I grabbed a few sheets of this tattoo transfer paper on eBay for fairly cheap to address the task. The process goes as such. First, sketch your design out on paper. Then, using this waxy tattoo transfer paper, trace over the design. Typically, I just trace the major features here, the spine and major leaves only, since this step gets a bit tedious. Then retrace this design with this fancy ink sheet underneath. The instructions mention using a ballpoint pen for this, but I found that placing the paper on top of something hard and using a pencil works best for me. Finally, deodorant, you filthy pig. I'm just pulling your leg. Well, your armpit hair at the very least. Just lather your workpiece up, relishing the smell of cleanliness and chemicals, then slap your waxy design on top. With a thin skin of deodorant and a bit of pressure on the paper, the lines come out clean and clear. Once it dries, the ink is very resilient. And with that, the last piece of the puzzle falls into place, and I can finally complete the masterpiece I set out to construct some 59 long years ago. Well, I hope you enjoyed. This video is a bit different than my usual format. I felt inclined to go into a bit more detail than usual, as I found the information out there on engraving relatively sparse, often locked behind paywalls or just fragmented and difficult to locate. Most of the information I found covered pneumatic handpiece engraving, for which the basics seem the same, but the one-handed nature of it is fundamentally different than the two-handed nature of the hammer and chisel. Well, that's my understanding of it anyway, as someone who has never even seen a pneumatic handpiece. If you're interested in learning more, my favorite YouTuber, Uri Tuchman, has a number of videos on the topic, which I learned quite a lot from. I'll link some below. Until next time, friends, in the immortal words of Step 3, keep your tips clean and shiny.